Hi, in this video I have the Mackie big knob. It has a fault. I have disassembled it. If you want to know how to disassemble it, please check out my video on a little service guide for the big knob. But nevertheless, this has a fault. The fault on the unit is that none of the lights here come on. So that would be this board over here. You press the buttons, there's nothing. None of these lights light up. The running lights do not work. We also cannot get any USB audio. So if I try and listen to some music, if I want to increase the volume on, say, the speakers, it doesn't work. Then the microphone, if I want to plug in the microphone, it also doesn't work. So it is almost completely not working except for one LED here, and the light does stay on. There's two lights that stay on here, and I just noticed that nothing else works. But I can see there is power here because one of these LEDs does come on. I've already done some fault tracing, and I'm going to tell you what I found, and also I'm going to demonstrate how I fixed this. For your reference, this is the version number of the main board. So I'm just plugging in the power cable now, and this is the power that will be plugged into this board. So I'm just going to power up the board, and I've switched the unit on. But how I determined the fault was as follows. I measured the voltage coming in. So there is where the voltage comes in, and that would be the 18 volts. So if I just show you, so there's the 18 volts coming in over there, and I followed it through this little power supply here. And what I noticed is these chokes here got really hot. Like this whole area around just started getting hot. So I'll just quickly show you the steps that I took to resolve this. If I put the one lead on the ground, so that means I'm going to put it there. That is the chassis or the ground. By L19 and L17, I noticed that the voltage should have been that 15 volts. And on the other one, there you can see the minus 15 volts. So that means that this power supply here is giving the positive and negative rails, because there's a lot of op amps here, and op amps need that positive and negative rail. When I put my lead here, I never got 14.9 volts, I got 1 point something volts. And it's the same on the top there. Then I mapped this out and I saw that it comes to this comparator. It's an op amp. I'm not sure exactly, I don't have the circuit diagram here, but I noticed that it comes to this IC, and this IC was actually warm, actually more like hot, and was getting hot. It seems like either this IC has failed or something else has failed. Before I removed this one pin, see there, that pin has been lifted. Then when I was measuring here, this would be the output of the power supply. I noticed it was at 1.5 volts and like minus like 0.5 volts. And then that was what was making these chokes here very hot. When I lifted the one leg of this comparator, then I noticed that I've got my dual rail power supply operating, because I'm just showing you again, there's the 15 volts for the positive, and there is the minus 15 volts now powering up everything. So once I lifted that one leg of this IC, most things worked. For example, the lights are now working. This before it didn't work. I can select the channel. It is actually on, but you might not see because it's light green, and these are working. The USB works, and I then reconnected this, put it to my computer, and actually everything worked. But the running lights stopped working. So the running lights did not work when I removed the leg of this IC. So I'm going to just hope for the best. So I ordered the IC. There it is. It happens to be the same brand. You don't have to use the same brand. So I actually have a spare just in case I stuff up. This is an ST branded one, but I also managed to locate the one that they used on the Mackie, and this is by On, and it's an LM339. So I'm going to desolder that one and solder this one in. If I don't have the right soldering on, but I'm going to do my best to just remove this. So if you have this problem where you find that you're measuring there and there and you just don't get any voltage, or the voltage is very low, and you find that these inductors here are getting hot, you just generally, this whole area is getting hot, and the voltage is low and the lights don't work and the unit pretty much does not work, then just measure there, L17 and 19. How I knew that this was being shorted to ground is I actually lifted it. So I desoldered the link. I desoldered this link, and once I desoldered it, on the one side it was the 15 volts, and on the other side obviously there was nothing. So I could see that this was the link that was being pulled to ground. That's how I was able to split the power supply side from the rest of the board. So it's here. You can also just lift one of these and then see if you're getting the minus 15 volts and the positive 15 volts. If you are, when these are lifted, then you know the fault is on this side of the board. Then you know, at least you know the power supply is working perfectly. Okay, so now I'm going to desolder this. This is going to be quite tricky. Of course, I'm going to switch it off and unplug it. All right, so I'm just going to insert something there on the edge. So it's trying to lift it up, and I'm going to heat up the leg as fast as possible and try and lift the IC at the same time. Ideally, if you had a hot air blower, this would be much easier. In my case, I don't have one. Since the IC is already damaged, it doesn't matter if I heat it up too much. All right, so I've lifted up the one side, not very well though, but it's done. Now I'm just going to flip this and work on the other side. Right, I've just set the meter to continuity, and I just want to show you the leg that I originally lifted up is this leg over here, and this is also the power leg for all of the ICs. This same leg here, if I go to L17, notice, you see it's a dead short. So this feeds all the ICs. So if one of these ICs fail, then it's obviously going to pull down the whole power supply. But unfortunately, I have made a little bit of a dog's breakfast here. So I'm just going to make sure that when I put this back, that I haven't stuffed this up. I forgot to mention that there's a capacitor there and a capacitor there. I took them out while I was fault tracing. So I still owe the board two capacitors, one there and one there. Right, one of the capacitors is actually there. And I just have this capacitance meter. I've set it to 200 nano, and I'm just going to measure what the capacitance was. And there I can see it's about 140 odd nanofarad. So I'm just going to replace the capacitor now. All right, I'm just replacing the one capacitor now. The one capacitor is there. The other one was not giving me any measurement, so I'm just replacing it. I don't have a surface mount. All right, so I've returned it for this giant capacitor. I will fold it down. Now I just need to put this IC back in. All right, to make this just a little bit easier to solder, I'm just tinning these tracks here. Okay, just going one leg at a time, depressing the IC from the top, and just trying to press it down nicely. And all the legs are soldered on that side. So now I can turn it on, and I'm going to measure at that pin 3 or here at this link to see if this is still pulling down the board. All right, so I've just plugged it in again and turn it on. No. So what I noticed is when I switched it on, things didn't actually work. I also did a voltage measurement over here, and I noticed that the voltage was low again, meaning that something is pulling this board down, the power supply. So I put my finger here and I could feel this little capacitor here was very hot. So with the power off, I'm just removing this capacitor. And I'm going to turn it on without that capacitor. Now, when I was doing my investigations, I noticed that the positive rail is on the one side and the negative rail is on the other side. So you're having a positive 15 and a negative 15. So between these two pins is 30 volts. And I wonder if something's wrong with that capacitor, because of course, if there's any ripple, it would move through that capacitor. Obviously, the capacitor is going to block the DC. So maybe there was a problem there. So I'm going to switch it on now with the capacitor removed. Yes, and there I can see the light has come on. Yes, it's like it's working. So that meant that something was wrong with that capacitor. I'm going to do a quick measurement on the link. There we go, minus 15. And on this side, we've got the 15. So that is working. Now I'm going to measure between where that capacitor was just to show you. There we go. There's that 30 volts. I'm going to insert another polyester capacitor and just see what happens. I'm going to turn it off now. All right, so I'm turning the power off to the unit. All right, so there are the two capacitors in place of the ones that were there. The one was getting very hot. It was also shorting out the voltage between those 2 points. All right, so I'm turning on. Yes, okay, so seems like it's okay. Now what I'm going to do is I'm going to leave it for like 20 minutes and just let it sit and then just feel the board. Remember, I've got no circuit diagrams and there's no advice on what to do here. So I'm really just guessing. All right, so it's actually been on for an hour and a half. And I've done my little tests here and everything seems to be fine. When it was faulty, these used to get very hot. I'm not feeling any unusual heat. I can see that the lights are still coming on. It seems like the power is still present for the other little ICs here. And what I'm going to do now is just give it a service. I just want to make sure these capacitors are not going to wobble. They are quite heavy, so I might put some glue and just push them down a little bit. I'm going to service all these knobs and these buttons. They tend to crackle, so I'll also show how I do that. All right, I've just resoldered these capacitors. I've made them flat. I've just confirmed that the capacitors are not in the way of anything. They're not touching anything. Just putting a tiny bit of glue here. I've just put a bit of cold glue here. It's not ideal. I don't like to put glue on components, but in this case, I actually have to because of the vibration in the studio, this capacitor might move. Now, the question is, was it the IC or was it the capacitor? Unfortunately, I don't know the answer to that question. So I may have just changed this IC for no reason. It may have just been the two surface mount capacitors. But nevertheless, I did change the IC. So in your case, you'll just have to see if it is the capacitor. You can just replace the capacitor and see if that stops the voltage from the power supply being shorted to ground. Right, now I'm going to quickly do a service. One of the problems of this unit, it has a crackling sound there, and then when you press the button, it's like sometimes it works, sometimes it doesn't. So you're just going to remove these little covers, and then to remove this, you just pinch it, and then you can remove the cover. Now I've exposed all the switches and all the knobs, and now what I'm going to do is I'm going to take a contact cleaner. I'm going to use this contact 60. I'm going to spray it on every switch inside the little holes here for these little potentiometers. And then I quickly turn this as many times as possible. You don't need to use a lot. This spray really penetrates. You really don't need to use a lot of it. It spreads very well. Leave this to dry for about an hour. Just let it evaporate, or you can blow it out. Right, after using the number 60, if you want to do this properly, you can then use the wash spray. So you just spray this in, and it's supposed to remove the oxides away. Right, so after using the contact 60, then the wash spray, then you can use this 61, and this then is an anti-corrosion agent. It stops the surfaces from corroding again. Of course, you don't have to do this whole elaborate spraying thing. You can just get a contact cleaner, which is one spray that does everything, and you will have a very good result if you just use the contact 60, but the correct way is to end off with the number 61, which is just a protection, provides a thin film of an anti-corrosion layer, and that's what they claim. So if you want to do it according to the manufacturer specification, just spray this in after you've allowed it to dry. So it must have already evaporated and dried before you do this step. The contact 61, you only spray a little bit just to coat it. Right, allow this to dry. Right, while I'm waiting for it to dry, I'm going to use this to populate this board, letting this dry nicely. So I'm just going to see where things go now. So that is there. The circuit board also prints the labels. So when inserting these plastic caps, they only go in one orientation. If it's the wrong way, it's a bit stiff. The button should move freely. Right, before I put this back, I can use this time to quickly give this a wipe down. Right, I just reseat the main board. Just check that you've replaced everything. These knobs get put on afterwards. All right, so there is a problem. Notice the lights there. There's the LED, but this one is not aligned properly. It's been bumped. So there's the culprit. It has shifted out of alignment. I'm now going to insert the screws one by one. Before finalizing the job, quickly check that all these lights have aligned properly and it depresses easily. They should all depress easily. And now return these cables one by one. Can only go one way, don't force it. Right, now I'm returning this board with the headphones plug in. It's 2 washers, they are flat washers. It almost levels the surface, 2 flat washers. I then place this over here. I then use a beveled washer and then the nut. I'm just plugging that in. Right, remember to plug in the output stage. This is for all the speakers. Now I just need to mount this USB board. It sits upside down and it's the black screws. Right, there are some press buttons here which you can also clean. There are some jacks here. You can also spray in a contact cleaner and then the protective film if you want to. Again, it's just a drop. You don't need a lot of this stuff. And then you just do this a few times. And then you blow it out with the blower. I just return the back cover now, and now the 10,000 screws. Now I just give these knobs a quick clean. I just use some rubbing alcohol and a toothbrush. So I got a little bit of brown, the dust gets in here, it doesn't look very nice. Return the washer, return the nut, give it a quarter of a turn. Turn all the knobs anti-clockwise, and now just put them on one by one. Right, the unit has now been repaired and it is now ready for use. Right, here's the unit, mute, mono, all the buttons work. There's the volume for the speakers, monitors A, monitors B, everything is working. I can play it for you. There is monitors A, monitor B. The mic also works. The mic is also working. There's no crackling whatsoever. The unit is now repaired. Notice the lights, 48 volts, the USB and the power. All right, instead of using my other audio interface, I'm now going to go back to the big knob. I'm going to use it for 5 days. If you find this video on YouTube and you're watching it, meant that the repair worked, and that's why I published the video. All right, I hope it's helpful. Thanks for watching, and cheers.